Hey everyone, and welcome back. Hopefully you enjoyed your reading week. Just some announcements to start off. First of all, you're going to have an optional activity starting. Um, I'll release it in the next couple days, and it'll be due the end of the week, so Friday, November 13th at 11:59 p.m. So this is an optional activity, which means that if you completed activity 1 and 2 and you don't want to submit activity 3, then I'm only going to count activities 1 and 2. But if you do submit activity 3 for whatever reason, then I will count activities 1, 2, and 3, just the average of those, for your activity mark. So that's it for the activity. Activity 3 is optional, again, and it's due this coming Friday, the 13th. The other two things, we have assignment 3, which I'm going to release maybe Tuesday this week, and that will be due on the 20th at 11:59 p.m. And then the final thing is assignment 4, and that's going to be coming out maybe Thursday or so, depending on when it gets written up, and that'll be due December 4th. So all of these assignments are sort of coming at you right now, but if you don't want to do activity 3, it's optional, which would just leave you with assignment 3 and 4, and those are about 2 weeks apart for the due date, with assignment 4 being available to you a bit earlier because it is a bit of a, it's worth a bit more. It's worth 20% of the mark. So that's it for the assignments and activities for the rest of the course. There's not going to be anything else other than the exam. Let's get into this video. Let's get into the topic. And the topic for this week is basically more data structures, focusing on the other really important ones. The most important one is going to be the dictionary, but that'll be the last thing we cover. For now, we'll start with Numpy arrays, and then the next video we'll move on to tuples and then finally dictionaries. So let's start with Numpy arrays. To use a Numpy array, since we're using Numpy, we first have to import Numpy. So we type import Numpy, and we can import it as some name. And the only reason to do this is that so that it's easier to type every time. Usually we do np, but you could have any name that you call it. So say you called it cat, then to use NumPy we would say cat dot whatever NumPy function. But we'll stick to np. That's the standard. So how do we make an array? We say we could say a equals np dot array, and within the brackets we have square brackets to define the array. This is just a one-dimensional array. It's 1 row and 3 columns. If we print this, we'll see that it's similar to a list, the difference being that there are no commas between the values. So visually, that's how you could tell an array from a list. There's some other differences, but let's first talk about some things that are similar between arrays and lists, and just some useful things, some ways to access them and change them. So to access an element of the array, we can just do square brackets, same as we would for a list, and we pick the element number. So to pick the 4, for example, I would select A1 because this is element 1, and this should print the 4. Similarly, if I want to pick the 2, then it would be A2. The 5 would be A0. Another thing that arrays have in common with lists is that they are mutable. So we can reassign some value in the array to something else. So we could say A4, or if this is a typo, there is no fourth element. What I meant to say is A1. What I'm trying to change is that this element here, the 4. So I'm going to change it to 9. And when I print A, we see that we are able to change NumPy arrays. So they are mutable, just like lists, but not like strings. Remember, strings are immutable. So something that's different between lists and NumPy arrays is that NumPy arrays are they're using NumPy, and there are lots of different sort of attributes that an array has that we can work with. So if we want to see what attributes we have, we can type dir of A. And we can see these are all the different attributes that we can call on for an array. So we could, for example, type a.view, and this would just show us our array. We could type a.toList. This would convert our array to a list. A.size would tell us the size of our array, and so on. We can sort the list. I would encourage you to go over this and just take a look. It's not like you necessarily have to memorize these things, but it's useful to know. So dir will show us all the different attributes. So we can try to use a couple of them. Let's first try to see the type of the values. Let's see what type each of these values in the array has. Normally we would just type 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 of whatever we want to know the type of, right? But if we want to know the type of the values within the array, this won't work for us. So you'll see we will get the type of A. It's a NumPy array. But to find the type of these elements, we have to type a.dtype. This will give us the data type of the values in the array. Okay, in this case they're integers. And if we want to change the types, we can just say, we can reassign A to be a.asType. So asType will say we want to convert the values in the array to a certain type, and the type we're going to pick, we can pick float, for example, float 32, and then when we print a.dtype, we should see now that instead of int 64 we have float 32s. And also when we print A, we should see that they have a dot at the end of each number, signifying that these are floats. Another useful thing with arrays, and something that's different from lists, is that if you want to append to the end of an array, you can't directly do it. You can't just say a.append 5, for example. Right? There's no attribute append. But you can call numpy.append, and you can append to an array in this way. So we could say a equals numpy.append. And what we'll do here, and sorry, we didn't call it numpy, we called it np, right? We imported numpy as np, so we'll type np.append. So we're going to add value 5 to our array A. So we'll type A, which is what we're appending to, and we're going to add 5. Now when we print A, we should see the value 5 has been added to the end. Notice that I am reassigning A to be equal to A with 5 appended. So if that's confusing to you, we could call it another name. We could call it B, and we could say our new array B will be equal to array A with 5 appended to it, and that's going to do the same thing. But in any case, whether we call it A again or B, we are creating a new array instead of appending to the existing array. 2D arrays. How do we make a 2D array? The notation is pretty similar. We just have an extra pair of square brackets. So let's type this, np.array, and we need 2 sets of square brackets. And within each row, we need square brackets. So we have 1, 2, 3. Just to follow this example, 1, 2, 3, 4, 5, 6, and 7, 8, 9. Okay, this is a 2-dimensional array. How many rows does it have? We have 1 row here, a 2nd row here, and a 3rd row here. So we have 3 rows. The number of columns, we have 3 entries per row, so we would have 3 columns. And when we print this, just to show what it looks like, we should see a 3x3 array. Okay, we can get the shape of the array. This is another attribute, and this should tell us that it's a 3x3. We could also slice the array. So we could, just like with lists, we could take a, let's just take from row, well let's print it first. Let's say we want to slice just the middle column and we want all of the rows. So the slice we will take will be A square brackets. You'll have a comma between rows and columns. So on the left is which rows you're selecting. We could select 0 to 2, which is all the rows. Or we could write simply this. This is also all the rows. And we want a particular column. So if we want 2, 5, and 8, we want column 1. If we wanted 1, 4, 7, it would be column 0. So if we print this, it won't print vertical like this, but it will print the values. It will print 2, 5, 8. So I'll run this, and we get the column values. Okay, another thing to add is we have Numpy has the ability to make an array of zeros, an array of ones, and so on. To do this, we just type a equals np dot zeros, and we can specify the shape. Let's say we want, for example, a 6x6 array of zeros. We can print this to make sure that it's creating this properly, and we should see a 6 row by 6 column array of zeros. This corresponding to the row, and this corresponding to the, not the row, the number of rows, and this corresponding to the number of columns. So that was a bit about NumPy, but there's so much more that you can do with it, and too much to cover in a short video. So I would encourage you on your own time to just take a look through this quick start tutorial. There's no pressure to go through it. You don't have to for the exam or anything, but you might find it useful for maybe the assignment or even any coding projects you do in the future. So that's going to be it for this video. In the next video, we'll talk about tuples.